Hello, good people. Here's our last video for partial fractions. I wanted to do number two to show you that sometimes we have to slow down and analyze what we're given and not do more work than we need and waste some time. So, for example, when I look at this at the beginning, I could look at it and say, oh, look, this is a bottom heavy situation, right? The denominator has a bigger degree than the top. And I can factor out x squared minus 4 into x minus 2 times x plus 2. So maybe I can do the partial fraction decomposition in order to take the antiderivative. However, you should also know or notice that if I set my denominator equal to u, that means du would be the derivative of this, which would be 2x dx. And that's exactly what I have. So therefore, I could just rewrite this as 2x dx, so that's du, over x squared minus 4, well, we said that was going to be u, and I have the natural log antiderivative, right? This would be the natural log of u absolute valued plus c. And then we can go back to the world of x's and say, oh, the natural log of x squared minus 4 absolute valued plus c. And then this would be my answer. So there really wouldn't be a reason for me to do partial fraction decomposition to figure out the antiderivative. So I can use u substitution to do that. So I wanted to do number two to point that out, that just because this is a bottom heavy rational function where the denominator has the bigger degree, that doesn't mean that it's automatic, and it's factorable. That doesn't mean I have to factor it and do partial fraction. But when I look at number three, well, this is already factored, number one. Number two, the derivative of the denominator is not in the numerator, and so the natural log idea won't work straight off. And so I'm going to do partial fraction decomposition. All right, so I went a little fast here, and it got a little sloppy. So all of this is equal to a over x plus 2 plus b over x minus 3 plus c over x plus 1, right? But we're going to multiply both sides by the common denominator. So that's going to leave me with a equals. Well, if I multiply this whole thing times each of these, when I multiply it times the first one, the x plus 2's are gone, and I'm left with this, plus b, the x minus 3's are going to cancel and reduce, and I'm left with this, plus c, the x plus 1's are going to reduce, and I'm left with this. I meant to put a c and a parentheses here. All right, so now we're going to test. And we're going to test with different values. So what if x equals 3? If f equals 3, x equals 3, 1 is not going to change. But this is going to zero out. This is going to be 3 plus 2 times 3 plus 1. And then this is going to zero out. So really, I'm left with 1 equals, this is 4, this is 5. So b times 20, and that would be 1/20th. b is equal to 1/20th. And then I pick another value. What if x equals negative 1? Well, I still have 1 here on the left side of the equal sign, but if I substitute negative 1, this thing's gone, and this thing's gone, but then I'm left with negative 1 plus 2 times negative 1 minus 3. So that's going to leave me with, this is going to be positive 1, this is going to be negative 4, so I'm left with c times negative 4. That means c is negative 1/4. So I'm going to pause here, or you can pause the video and kind of recapture all that quick work. And then what if x equals negative 2? Well, 1 is still there. A times negative 2 minus 3 times negative 2 plus 1. But when I substitute negative 2 in here, this is going to become 0. 0 times everything is going to zero that out. Negative 2 plus 2 is 0, and that's going to zero that out. So this is all I'm left with. 1 equals negative 5 times, well, here, I'll do this. Negative 5 times negative 3, so that's 15. This is negative 5. This is negative 3. Oh, I'm sorry. Is it negative 3? No, it's negative 1. I can't see the line. All right, so it's negative 2 plus 1, that's negative 1. So that's going to give me 5. So A is 1/5. Mm-mm. Just making sure I got everything in the right spot. I think I do. So now I can do the partial fraction decomposition of this integrand. So this is really the integral of A, which is 1/5. And you know what? I'm going to go ahead and write the 1/5 on the outside because it's a constant. 1 over x plus 2 dx plus b, which is 1/20th, times the integral of 1 over x minus 3 dx plus c, which is negative 1/4, times the integral of 1 over x plus 1 dx. And I can use the natural log antiderivative, natural log of the absolute value of x plus 2, plus 1/20th times the natural log of the absolute value of x minus 3, minus 1/4 times the natural log of x plus 1, absolute value plus c. And here is my answer. Now, if we had to combine these, we could combine these, remembering the rules of logs. That say if I'm adding logs, I can put them together through multiplication of the argument that's inside of the log. And if I'm subtracting, I would divide. But we can get into that specificity in class. This is where I want you to be able to get to, because this is telling us that we do know how to take the antiderivative using one of several methods, one of which was doing long division, one of them was just doing U substitution, one of them was completing the square, and now this one is using partial fraction decomposition, breaking a fraction up into little fractions so that I can take the antiderivative of each of them and get the answer.